All right. Starting with our 14.6, and this will be the last one that we do in this chapter. And it's talking about quadrilaterals, okay, and angle sums. Okay, now, quadrilaterals, okay, are four-sided figures. That's why we call them quadrilaterals, because of the word quad. Okay, the word quad, or the prefix before the word, we say quadrilateral, means four. Okay, so all the figures that we're going to talk about today have four sides. Okay, now, there's different types of quadrilaterals. Okay, there is a parallelogram, which we have said is a quadrilateral with opposite sides are parallel. When we say opposite sides are parallel, that's what the little marks mean right there. There's two marks there, and so that means that those sides are parallel to each other. Okay, obviously the other two sides are also parallel to each other. In other words, the opposite sides are parallel. Okay, opposite sides and opposite angles are also congruent. Okay, so this right here is congruent to each other. Okay, the length of it is. Okay, on a parallelogram, it does not have to have 90-degree angles all the way around. Okay, a parallelogram, once again, is just a four-sided figure, okay, with opposite sides parallel and then opposite angles and sides are congruent. Now, the difference between a parallelogram and a rectangle, okay? A rectangle is a quadrilateral with four right angles, okay? It is also a parallelogram, but it is a special kind of parallelogram. Okay, all the things that we're going to really talk about today are parallelograms, okay? There are special types of parallelograms more than just a parallelogram. And they have a special, like this one, all 90-degree angles. Okay, that's what makes this one different than a regular parallelogram. A regular parallelogram does not have to have 90-degree angles. Okay? Now, the next one, obviously the square. The square has 90-degree angles, okay, with its sides all congruent. Okay, so basically it's a rectangle, but the difference between a rectangle and a square is on the square all the sides are the same. Okay, but it is a rectangle. And a rectangle is a parallelogram, so therefore a square has to be a parallelogram. All right. On the rhombus, a rhombus is a parallelogram with all sides congruent. Okay? It is all sides are congruent, not the angles. Okay, just the sides. If all the sides and all the angles are congruent, then it'd be a square. Okay, so a rhombus, the best way to think about a rhombus besides the picture that's drawn right there is to think of a diamond. Okay? If you think of a diamond, and let's see here. Yeah, if you think of a diamond, a lot of times people will draw a baseball diamond like that, sort of. Well, that was terrible. Bring it up a little bit further. Okay, think of a baseball diamond. And a baseball diamond, they call it the baseball diamond. All the sides are congruent, okay, because all the base paths are congruent. In other words, it's either 60 feet between each base, or it's 90 feet between each base, or 80 feet between each base. And so it is what we would consider more so a square than a rhombus, because all the angles would be the same too. Okay? And so, but a rhombus is more like a diamond. It has all sides congruent. A trapezoid is the last type, and that is a quadrilateral. You notice I did not say parallelogram. Okay, it does not belong in the category of parallelogram. The reason it doesn't belong in the category of parallelogram is because both pair of sides are not parallel. Okay, you can see in that figure right there that one pair of sides is parallel. Okay, and that's the definition of quadrilateral. It's exactly one pair of parallel sides. But you will see that these two sides are not parallel. In other words, those two sides, here and here, would eventually intersect each other. They're also not the same distance apart. In other words, the distance from here to here and the distance from here to here is not the same. So therefore, they can't be parallel. Okay, and so a trapezoid is the only one of these that does not belong in the parallelogram category. Okay, so the parallelogram is 1, 2, 3 different types of parallelograms. The trapezoid is a quadrilateral. Okay, it is not a parallelogram. All right, now, that brings us to our last definition in this section, and that's the word diagonal. Okay? And it says there, a diagonal is a line segment that connects opposite vertices of a closed figure. Okay? Vertices are basically the plural for vertex. We said the vertex is the common endpoint in an angle. Okay? So what they're talking about then is these are vertex. Okay? And when you talk about more than one vertex, it's called a vertices. Okay? Which means that's plural for the word vertex. Okay? So a diagonal is a straight line that connects one vertex with another vertex. Obviously here, we could draw another diagonal across and join that, forming an X. Okay? But they have not done that. They only want to do the one diagonal. Now, you will also notice that when I do draw a diagonal across a quadrilateral, I get what? That diagonal has done what to that figure? I'll give you a hint. What did we talk about in the last section? Brandon, what did we talk about in the last section? Joy just told you. Or Michael, well, somebody over here did. Huh? Yes, we talked about triangles. We talked about triangles, and don't I have two triangles that has been created by a diagonal? Now, who can tell me or who remembers, and you do have a test on Wednesday in here over chapter 14. I'll hand you a review sheet at the end of class for the definitions that you're going to need to know. But you're going to need to know all this stuff. All this stuff that we've talked about in this chapter is going to show up on the test in one form or the other. Okay? Now, who can tell me the measurement of those three angles in that triangle would have to be equal to what, Joy? 180 degrees. Okay? So, if there's two triangles then in this quadrilateral, what do these four angles have to add up to be? If there's two triangles in the quadrilateral, and each triangle has to have 180 degrees for its three angles, what are the four angles of the quadrilateral going to be? Michael? Yes, 360 degrees. So if you can read the screen, or maybe you used your brain, okay, it's right there on the screen. says each triangle has an angle sum of 180 degrees, so the angle sum of any quadrilateral is 2 times 180, which is 360. Okay, hopefully you used your brain and you didn't have to use the board for help. Okay, now, having said that, I want to look at this figure that they've drawn for us. Now, what kind of figure, besides being a quadrilateral, what kind of figure is that? In our special name category, what kind of figure would that be, Jonah? Yeah, it's a trapezoid, okay? Because you can obviously see that there's only one pair of sides here and here that are parallel to each other. The other two sides would eventually intersect each other if we continued them on that same plane, okay? Now, I'm going to erase everything that's on there, okay? I want to look at the missing measurement right there, N. Okay? What would that measurement have to be? For that angle N, what would it have to be? Brandon? 40 degrees. Why 40? Yeah. If we add, in other words, we take this figure and we say, okay, 110 plus 30 plus the N has to equal 180 degrees. Okay? If you take those and put those two things together, that means, like Brandon said, we have 140 plus N equal 180. So we'd subtract 140 from both sides. That cancels on the left side, leaving me with N. And 180 minus 140 is 40 degrees. You really must put the degree sign for the answer to be correct. If not, then we could be talking about money. We could be talking about, how old someone is. We could be talking about a lot of different things. Okay, so we really need to have that degree sign in there as well. Okay. So, fairly simplistic. Okay, the other way you could have done it had been a little harder. You could have taken 110, 30, 90, 60, 30 and add those up together and subtract that from 360. Okay, and you would have the same answer. All right, now let's look at page 369. Let's look at number 1. Okay. Page 369, and let's look at number 1. Not keeping you up, I hope, Joy. All right, number 1 looks sort of like that. Drawing was never my strong suit, not even stick figures. And that's one of the many reasons why I'm a math teacher, not an art teacher. Okay? Now, what they want us to do is, they want us to take this figure, number 1, and the directions say this. Find each missing angle measure, then classify each figure as a quadrilateral, parallelogram, rectangle, rhombus, square, or trapezoid. Include all classifications that apply. Okay? So, what is the missing measurement here? Do what? Oh, yeah, N's the missing measurement, but what is that measurement? Yeah, I know N is the missing one. What is the missing one? Jonah, what do you think? 110, that is correct. N is equal to 110 degrees. Okay? Now we must classify this figure. Noah. Okay, trapezoid. What else? Jonah. No. Not a parallelogram. What do we say a trapezoid was? Staley. A quadrilateral. A trapezoid is a quadrilateral. Right here. Okay? It is a quadrilateral. It is not a parallelogram because both pair of sides have to be parallel to each other for it to be a parallelogram. Okay? That's the word parallelogram. All right? Now, so that's it on that one. Fairly simplistic. Let's look at number 2. Number 2 has 120, 60, in, and 60. Okay, so what is the missing measurement? Emily? 120, yes. N is equal to 120 degrees, okay? So, this is 120. So, what is the classification of this figure? Remember, we must include everything that applies. Noah? Yep, a parallelogram. Brandon? A rhombus? No, we don't know it's a rhombus. We don't know it's a rhombus because they don't give us the marks on the side like the rhombus has up in our example. There is another one, but it's not rhombus. Jonah? No, not a rectangle. Because what does a rectangle have to have? What makes it a rectangle? Okay. Does that have any right angles? No. So it can't be a rectangle. Okay. Noah? Yes, it is a quadrilateral. Any four-sided figure is a quadrilateral. Okay? Any four-sided figure is going to be a quadrilateral. Let's see here. Look at number 3. So you have 30, 130, N, and 60. So what is N? Noah? 120? Let's see. No. Have 30. Is that 30 right? Oh, it's 50. My bad. That's 50. That would be correct. I can't read my writing. So that'd be 180, 240, and you said 120, correct? Yeah, it's 120. Yeah, I can't read my writing. All right, so it's 120 degrees. This is not a trapezoid. Okay? The reason it's not a trapezoid because these two lines are not really parallel, and neither is this one. This one has a little angle to it where it's going down like that, so if you continued it up, it'd eventually run into this one. So the only thing you can say about this one is that for sure It is a quadrilateral because it has 4 sides. So n is equal to 120, and it is a quadrilateral. Okay? All right. So your homework, of which we just did 3 of them, is going to be not very long. 14.6, 1 through 10. All right. Still got time left in class. Still got about almost 10 minutes left.